right, second problem associated with working with complementary angles. It's problem 22, page 519. You have something similar in problem 21, and I'm looking at it now, and yeah, they're pretty similar problems. So, again, last time, I showed this two times. What we're working with is the complementary angle theorem, which says the cosine of theta is equal to the sine of 90 minus theta, essentially. And like I said, we've known that for some time when we first made the observation that the graph of the sine and the cosine are the same function, just shifted in phase by 90. And now, so you have it from that perspective, and now we've got it sort of from the right triangle perspective. I think I showed this last time. If this is 40, this is 50, because we got to add up to 180, and this right triangle has got a 90 right there. So let me just call it A, B, C again. And if I want to calculate the cosine of 40, I need the adjacent over the hypotenuse. And if I want to calculate the sine of 50, I need the opposite over the hypotenuse, which is the same thing again. So there we see it. Cosine of 40 is equal to sine of 50. This is going to be equal to 1. I'm not sure I want to do, let me do this time. Let me call the sine of 50 equal to the sine of 90 minus 40, since I'm pretty sure 90 minus 40 is 50. And then let me say that the sine of 90 minus 40 is equal to the sine of 90 times the cosine of 40 minus cosine of 90 sine of 40. And let me run through this. What is the sine of 90? At pi over 2 and 90 degrees, sine is equal to 1, so this becomes cosine 40. And minus cosine 90, cosine 90 is equal to 0. And so this term goes away. Indeed, the sine of 50 degrees is equal to the sine of 90 minus 40, which is equal to cosine 40. Sine 50 is equal to cosine 40. That thing's equal to 1.